The age of the robot has arrived. They may not yet be clanking around your house with a feather duster, but in the factory, they've become essential to the manufacturing process, rolling out everything from light bulbs to cars and cranes. But the one thing robots can't make is other robots. So, how do they do it? There are now over 1 million factory robots in the world. And the number of these mechanical wonder workers is swelling at the rate of over 100,000 a year. Working at an inhuman level of precision and speed, robots have increased productivity and decreased production cost. The result is that yesterday's luxury items are today's everyday disposables. At the 5 million square foot BMW car plant in Munich, 650 robots can produce 900 cars a day. But the robots that build the cars aren't built by the car manufacturer. They come from this place, KUKA Robotics in Augsburg, Bavaria. 150 people work here, producing an awesome 10,000 robots a year. But you won't find anyone here worrying about machines taking over the world. Like everyone at KUKA, Director of Global Production Udo Eireth loves his robots.
The robot is usually always friendly to the human being. The human being is not always friendly to the robot. The human mind is the limitation, not the robot itself.
This 2.5-ton RoboCoaster is the world's first passenger-carrying robot. It can lift up to 1,000 pounds and take 2 thrill seekers from nervous to nauseous in seconds. While this robot arm might be the fairground ride of the future, the robots that do real jobs like building cars aren't that different. They certainly don't need sci-fi accessories like heads or even legs. For most industrial jobs, an arm and a hand will do. A car-building robot arm is made from 750 parts. That's 3 times the number of parts as there are bones in your entire body. Just like a human arm, the KUKA robot has a shoulder, upper arm, forearm, and wrist. But instead of a frail human body, it's connected to a sturdy mechanical base. A human shoulder, elbow, and wrist can make an almost infinite number of different movements, giving us the mobility for incredible feats of tool handling. The joints in a robot arm can only rotate along one axis. But they more than compensate for this with twice as many joints as a human arm. However, it takes more than uber flexibility to make a super productive industrial robot. It also takes muscle. To give it the strength it needs, each arm is fitted with no fewer than 6 powerful servo motors, giving a robot arm the equivalent horsepower of a medium-sized car, and 100 times the torque, allowing KUKA's largest robot to lift a hefty 3,000 pounds and to reach over 10 feet. That takes care of flexibility and power. But how about accuracy? What you don't want is a line of clumsy giants working on your production line. The secret of the robots in human precision lies in their motors. The stepper motors that power the joints use multiple electromagnets to allow them to turn a limb in tiny fractions of a degree. This enables the robot arm to move repeatedly to within 1/10 of a millimeter and repeat the movement over and over again. But the human worker has one major advantage over a robot. No robotic device can match the extraordinary dexterity of a human hand, which can adapt to handle a variety of complex processes. So the KUKA robots cheat by changing their hands, depending on what job they are performing. Armed with these add-ons, the robot can turn its hand into anything from a welder or drill to a glue gun or screwdriver. But whether you put a carnival ride or an arc welder on the end of its arm, there's still one thing a robot can't do. And that's Think for Itself. When the first digital robot was programmed in 1961, it required a lot of clever math and a computer the size of a motorcade. Today, an operator sits down at a PC and uses a three-dimensional motion plan to create the job function, then saves the commands onto a small memory stick. Then the memory device is inserted into the robot's control panel and commands are downloaded. And immediately, the robot swings into action. For jobs that are a bit more creative and don't have a motion plan, a human operator can remotely guide the arm to establish a pattern for the robot to follow. And they'll remember the move and recreate it flawlessly, time after time. New recruits to KUKA's robot army are programmed and practice their maneuvers again and again in their cubicles as they await their assignment. From here, they are packed up and shipped off around the world to help with the production of everything from orange juice to automobiles. Back at the BMW body shop, the KUKA robots are lined up along 7 miles of conveyors. 12 synchronized KUKA robot arms work together to complete the bodywork of a new car in less than 3 minutes. Farther down the line, another robot fitted with spray guns can paint the car in less than 5 minutes. Of course, robots are only as smart as the people who make them, which makes humans far superior. Still to come, how do they turn tree bark into bottle plugs for the finest wines? Join us after the break to find out how.